For section 3.5, using exponential equations, we'll start with example 1. Part 1. If an initial investment is made of $2,000 at an annual interest rate of 6.5%, that is compounding continuously. Part A, how long does that take to double that investment? So if I'm using an exponential equation that has an interest rate being compounded continuously, those are keywords that make me think I'm going to use the PERT equation. The PERT formula has a continuously compounded interest, and then I should be able to find the answer to this problem. So how long does it take to double that investment? I'm going to start with an investment of $2,000, so I'm looking to turn that into $4,000 if I'm going to double it. So let's go ahead and get started. If I'm looking for how long it takes to double the investment, I'm looking at finding T. So I won't be able to plug in anything for T. A is my ending amount. I want to end at 4,000. P is my initial amount. I want to start at 2,000. E is an irrational number, constant, so I'll leave it as E. R is 6.5% written in decimal form, 0.065, and then I'm solving for T. So the first thing I'll do is divide both sides by 2,000. When you're doing these, you are trying to get your base and your exponent alone, so that gets rid of my 2,000 on the right. 2 equals e to the 0.065t. Then I have t in the exponent. I'd like that not to be in the exponent, and so what I'm going to do is switch to log form. Anytime you switch forms, you're going to get closer to your solution if t is in the exponent. So I'll write log base e of 2 equals 0.065t. So this is me switching forms. Log base e is natural log of 2. And then I just want to solve for t, so I will divide both sides by 0.065. So t equals ln of 2 divided by 0.065. So t ends up being about 10.66 years. That's the answer to part A. And I'll switch to part B. What is the amount in the account after 20 years? So now I'm not doing the whole doubling thing. I still will use the 2,000. I'll still use the interest rate, but I won't use the ending at 4,000 because I'm asked for the amount in the account, so I don't know the ending amount. So I'll still use 2,000 for P. I'll still use 0.065 for R, and then it says the time is 20. So plug all that in my calculator, no solving, everything's already on the right. 2,000 e to the 0.065 times 20. So that is $7,338.59. All right, part 2 is if you invest $3,000 and it grows to $8,000 in 10 years, what is the annual interest rate? So I am given, no other information that says, or it's still part 1, I guess, so I'm still compounding continuously. So I'm still going to use the PERT formula. It says that my ending amount has to be 8,000. My initial amount is 3,000. E is my constant. R is I don't know. And then 10 is my t. So I'll solve that very similarly to solving A in part 1. I'll start with dividing both sides by 3,000. And I'm just going to leave that as 8/3. Then I have R in the exponent. If you want something to be not in the exponent, you should switch forms. So I'm going to switch to log form. So it will be log base E of 8/3 equals R times 10. log base e is the same as ln, so natural log of 8/3 equals 10r. And the last thing I'll do is divide by 10. So I can get r by, in my calculator, taking ln of 8/3 and dividing by 10. So I got 0.0981, so that'd be about 9.8%.